In this video, we will see a coding example. So in week 1, we have already built our first neural network model, which was for a binary classification problem. Now in this video, we would see what are the small changes I have to make to the code of binary classification model to convert it into a multi-classification model. So for the first step is import all the necessary libraries. So all the necessary libraries are imported. As you can see, I am working with the Keras API integrated into TensorFlow. So that is why TensorFlow dot Keras. So all these libraries are the same which I have used for my first week coding, but also I have imported another library from NumPy, another class from my library NumPy, which is argmax. The second step is of course to load the data set, and for the purpose of this video I have selected an iris data set. So as we know, the iris data set consists of 4 attributes of 4 columns, and its target Y consists of 3 classes or 3 categories. One which is Thethosta, second one which is versicolor, and third one which is Virginica. So this is a multi-class classification problem with 3 different classes. Moving forward to data pre-processing, it is the exact same code which I have used for my video on binary classification problem. Now for this iris data set also, since we can see that the Y value, the labels are text values, I need to do a label encoding also, like what we have done for our binary example. So that is done in the data pre-processing step. Again, it is the same code from that of my binary classification model, right? Moving on to the life cycle of my Keras model. Now here is a portion of the code where you will see I have made some major tweaks in order to make this code suitable for a multi-class classification problem. So as we know, we are building a sequential model, that is, I am building one layer on top of each other, or in short, the output of one layer goes as input to the next layer. So here also I have 2 hidden layers, and this is my first hidden layer which has got 10 neuron. The activation function I have used is ReLU. I need to do my weight initialization, and for that I have chosen the He normal initialization, and then the input to my first hidden layer is nothing but my features. So number of features, as we know, the number of features for our iris data set is 4. And then moving on to my second hidden layer, again I have used 8 neurons in my second hidden layer. Activation function ReLU, kernel initialization is He normal. Now in my output layer, you can see 2 major changes that I have made with regards to the code for binary classification. The first one is that you could see now I have 3 output nodes or neurons in my output layer. So in my output layer, I have 3 neurons. And why 3 neurons is because I have 3 classes for my iris data set. And as you can see, I have used my activation function as softmax, because softmax is the activation function that I should be using in my output layer if I am trying to solve a multi-class classification problem. Now, if this was a binary classification problem rather than the softmax, I would have used sigmoid, right? And then the same procedure. So the next step is to compile the model. Here again you can see one change I have made, which is on the loss function. So loss function or error function or cost function, right? So if this was a binary classification problem, if you remember from week 1, I have used a binary cross entropy. Right? Now here, since it is a multi-class classification problem, I use a different loss function, which is sparse categorical cross entropy. Right? Other than that, I have used my same optimizer, which is Adam, and the performance metrics as accuracy. And then I fit my model. This is the same exact code from my binary model, and then I evaluate my model, and finally I try to make predictions on my new data point. Right? And when I have already run this model, so I get an accuracy of approximately 0.96, and then according to this particular row, for this particular input or this particular new data I have given, it says that the probability of it belonging to class 0 is 0.003, class 1 is 0.96, and class 2 is 0.03. So since 0.96 is higher, we say it belongs to class 1. So that is where this function argmax comes into play. So argmax on y hat will actually give you the class to which this particular this particular new record we are testing belongs to. So let us give few more examples. And so I forgot to rerun my model. I ran it on a different data set. That's why we got class 0 for this input. But this input belongs to class 0 and not class 1. So let us go ahead and try some other examples. So we will try this particular value and see what is the class. So when I run it, it tells me that it belongs to class 1. And finally, one more value we will try. And when I run it, it says that it belongs to my class 2. Why? Because this represents the probability it belongs to 0. This represents the probability it belongs to class 1, and this represents the probability it belongs to class 2. So since class 2 has the highest probability, we say that this particular record belongs to class 2. So this is a very simple multi-class classification model. So there are few tweaks we have to do on our binary model to convert that code into a multi-class classification problem.